Welcome. Today we take few problems on ellipse. First problem is the focus of x square by a square plus y square by b square is equal to 1 are at plus minus 3b by 2 comma 0, then its eccentricity is options 7 by 2, root 7 by 2, sorry, it is actually 2 by root 13, 3 by root 13, 2 by 7, 3 by 7. These are the options. Okay, so it is a standard form of ellipse, and given that its focus is at that point whose x coordinate is 3b by 2 plus minus and y coordinate is 0, it means it lies on x axis. So for this problem, major axis is x axis, because on major axis focus is there. So the equation is of that type. One focus S is at 3b by 2 comma 0. So it is clear that A is greater than B. Therefore, it's in that standard equation, coordinate of focus is AE comma 0. So that we can take AE is equal to 3b by 2. So that B by A is equal to 2 by 3 into E. 2E. Actually, B by A is equal to 2E by 3. Okay. Again, eccentricity is equal, can be obtained from this formula. E square is equal to 1 minus b square by a square. 1 minus b by a is that. So b square by a square is equal to 4 by 9 square. Taking this into that side, so 1 plus 4 by 9 square is equal to 1. That is 13 by 9 square is equal to 1. So E is equal to 3 by root 13. 3E is equal to, E square is equal to 9 by 13, E is equal to 3 by root 13. This is correct answer. My next problem. Semilettuce rectum of an ellipse is half of its semi-major axis. One equation of ellipse not given, but given that for a ellipse, its semi-latus rectum. Length of latus rectum is 2b square by a. So semi-latus rectum is b square by a. It is given as half of its semi-major axis. Half of semi-major axis. Major axis is 2a, semi-major axis is a. So that this. Then problem is to find its eccentricity. Its eccentricity is how much? That is a problem, and options are there. It is half, 1 by root 2, 1 by root 3, and 1 by root 5. So in that case, equation is not given, but one property is given that length of semi-latus rectum is equal to half of the semi-major axis. It is given. So given is this thing. We have to find E. Now for that, once again we get b square by a square is equal to half. This half. And to find E square actually is equal to 1 minus b square by a square is equal to 1 minus b square by a square is your half. So that they together is half. So E is equal to 1 by root 2, not plus minus, 1 by root 2, because eccentricity it cannot be negative. So this is correct option. Now, next problem, the eccentric angle of a point in first quadrant of x square by 10 plus y square by 8 is equal to 1, which is at a distance of 3 units from center. Now, here the problem is, one, ellipse is given in standard form, and one point in first quadrant such that its distance from origin is 3 units. Origin means center. Its distance from center is 3 units. To find the eccentric angle of that point. Eccentric angle not yet defined, I think. You see, what is eccentric angle? Suppose this is an ellipse. Its major axis is x-axis. Now draw auxiliary circle of that ellipse, means treating major axis as diameter, one circle is drawn. Suppose this is auxiliary circle. Auxiliary circle means, once again I am repeating, auxiliary circle is the circle whose one of the diameter is the major axis of the ellipse. Now suppose P is a point over there on the ellipse, not auxiliary circle. P is a point on that. eccentric angle of the point P is actually for that purpose you draw perpendicular to axis, say it is PN, extend it up to auxiliary circle, then join the point with center. That angle is called eccentric angle of the point P. This angle is eccentric angle of the point P. This is definition. But for calculation, we can take P as any point P, parametric form is A cos theta, B sin theta. Then that theta can be treated as eccentric angle of the point P, which satisfies the given condition. The condition is here is that in this case, A square is equal to 10, B square is equal to 8. So in our case, present case, the point can be taken as A cos theta. A means root 10 cos theta, and B means root 8 sin theta. And our condition is that from the point P to C center, that distance is CP is equal to 3. That is 9 is equal to CP square is equal to this to center is 0, 0. It is equal to CP square is equal to 9 is equal to CP square is 10 cos square theta plus 8 sin square theta. Then we have to solve for theta. It is equal to 10 cos square theta plus 8 into 1 minus cos square theta. That is 2 cos square theta plus 8. So that 2 cos square theta is equal to 1. That is cos theta is equal to 1 by root 2. Cos square theta is equal to 1 by 2. Cos theta is equal to 1 by root 2. So, which can be written as cos of pi by 4. So, theta is pi by 4. So, eccentric angle of the point P, whose distance from center is 3, is pi by 4. Oh, sorry, options are not given. Options were pi by 3, pi by 6, pi by 2, and pi by 4. So this is the correct option. Next problem. So one new term, eccentric angle. Now, next problem. S and T are focus of an ellipse, and B is the point of endpoint of minor axis. If SBT is an equilateral triangle, eccentricity of the ellipse is options 1 by 4, 1 by 3, half, and 1 by root 3. So, given that this is a ellipse, this is an ellipse, major axis minor axis, it is A dashed A, this is B dashed B. S and S dashed are focus. B is one endpoint of the minor axis, and given that BS is dashed is a equilateral triangle, means this is 60 degree, all angles are 60 degree. So here S, coordinate of S is equal to AE, 0 in standard form, AE, 0. B, coordinate of B is 0, B. Endpoint of this is 2B, so B. So from this triangle BCS, triangle BCS, it is actually CS by CB, base divided by height. This is equal to 10, or base divided by height, so that it is equal to cot 60 degree. CS, it is equal to C2A, center to S, AE, by CB is B, is equal to cot 30 degree, it cot 60 degree, it is 1 by root 3. That is B by A is equal to root 3 E. We have to find eccentricity of the ellipse, but formula of eccentricity is E square is equal to 1 minus B square by A square is equal to 1 minus 3 square, so that 4 square is equal to 1. So E is equal to root over of 1 by 4, so 1 by 2, not plus minus. Mind that eccentricity, it is ratio of lengths, so positive. So it is equal to 1 by 2. So option C is correct. Next. Oh, sorry. Last problem, that problem, just now I mentioned, it is given in the year West Bengal in the year 10, and before that problem, the eccentric angle lies in first quadrant of the ellipse, x square by 10 plus y square by 8. That problem, it was given in WBJEE in the year 2012. Yes, next problem. The eccentricity of the ellipse 4x square plus 16y square minus 24x minus 32y is equal to 1 is options. Root 3 by 2, 1 by 2, 1 by root 3, and root 3 by 4. And that problem was given in 2006. We have to find the eccentricity of that ellipse. That the equation of the ellipse is not standard form. It can be written as 4 into minus 6x plus 16 into y square minus 2y is equal to 1. So by adding here 9 means 3 square, and by adding here 1 we can make it a perfect square, that also a perfect square. So on left I have taken 4 into 9, 36, 16 into 1, that is 16. So balance it by, it is 36 plus 16. So that right hand side is 353. So this plus this is equal to 53. That is 4 into x minus 3 whole square plus 16 into y minus 1 whole square is equal to 53. So that x minus 3 whole square by 53, 53 by that 4 will be there, plus 16 into y minus 1 whole square by 53 by 16 is equal to 1. Now it is standard form, and we can write it as x square by 53 by 4 plus, not that, 16 is not there, it is given here, y square by 53 by 16 is equal to 1. Now it is of a standard form, but variables are not small x, small y. Variables are capital X and capital Y, where capital X is equal to x minus 3 and capital Y is y minus 1. Actually, I have shifted the origin. So in that standard form, equation is that, and a square is equal to this, b square is equal to that. A square is greater than that because 53 by 4 is more than 53 by 16. So this is major axis, this is my x axis is major axis, y axis is minor axis. So that in this case, equation of major axis, okay. I mean eccentricity can be written as E square is equal to 1 minus b square by a square by 53 by 4. So that it is equal to 1 minus 4 by 16. 1 by 4, 1 minus 1 by 4 is 3 by 4. So eccentricity E is equal to root 3 by 2. So this is eccentricity. Next. Next problem. If alpha and beta are eccentric angles at the two ends of a focal chord of x square by a square, just 1 minute. X square by a square plus y square by b square is equal to 1 then eccentricity of the ellipse is options. Sine of alpha plus beta by sine alpha minus sine beta, cos of alpha plus beta divided by sine alpha minus sine beta, cos of alpha minus beta by sine alpha minus sine beta, and finally sine of alpha minus beta by sine alpha minus sine beta. So the problem is equation of a ellipse in standard form is given. Then alpha, and given that alpha and beta are eccentric angles at the two ends of the focal chord of that, means suppose this is the ellipse, this is a focus, so this is a focal chord PS, not S, S is focus, PQ, and alpha and beta are eccentric angle at this point and at that point. So coordinate of P can be taken as A cos alpha, B sin alpha. Its that end, second end Q, its eccentric angle is beta. So it is equal to A cos beta, B sin beta. Focus, it is simply AE, 0. Now from this information we have to find eccentricity of the ellipse, and these are the options. Now the clue is how to find. The clue is PSQ, these 3 points are collinear. So area of the triangle formed by them will be 0. From that information we can find the eccentricity. The area of the triangle of PSQ is 0, so it can be obtained from this fact. Coordinate of P is A cos alpha, B sin alpha. Then S is AE 0. This is A cos beta, B sin beta, and repeat this one again, A cos alpha, B sin alpha. Therefore, area of the triangle is 0, means 0 is equal to half of, it is this into 0, this into that is AB, ABE sin beta, this into that, then this into this, AB sin alpha cos beta, minus, now this into that, ABE sin alpha, this into that 0, this into this, AB sin beta cos alpha. So that AB can be taken common and can be cancelled with 0. So that thing left is E into sin beta plus sin alpha cos beta minus A minus E sin alpha minus sin beta cos alpha. So we get E into sin beta minus sin alpha is equal to sin beta cos alpha minus sin alpha cos beta. It is equal to sin of beta minus alpha. Hence, E is equal to sin of beta minus alpha by sin beta minus sin alpha. It is correct answer. Oh. Sin of alpha minus beta by sin alpha minus sin beta. Multiply numerator and denominator by -1 minus, we get the answer D. Option D is correct. So base. Next. Next problem. X plus 2y is equal to 0 and 4x minus 3y is equal to 0 are two conjugate diameters of x square by 36 minus, not minus, plus y square by b square is equal to 1, given b square is less than 36. Then equation of directrices. Options: x is equal to plus minus 6, y is equal to plus minus 2 into root 6, then x is equal to plus minus 6 root 3, and y is equal to plus minus 6 root 2. These are the options. Achha, here in that problem, a new term, equation of conjugate diameters. Let us see what is that. To conjugate this and that are two conjugate diameters of this ellipse. Here b square is less than 36, means this is major axis. Suppose this is the ellipse and this is the major axis, minor axis. This is any chord passing through center is diameter. So this is a diameter, this is another diameter. Their equations must be of the form y is equal to m1x, suppose this one, and this is also again equal to y is equal to m2x, because they are passing through origin, no constant term. They will be conjugate diameter if m1 into m2, product of their gradients, is equal to minus b square by a square. This is the property. m1, m2 is equal to minus b square by a square. Or this can be obtained, suppose P and Q are two endpoints of the conjugate diameters. If coordinate of P is a cos theta, b sin theta, then that of Q will be a cos of pi by 2 plus theta, that is theta plus pi by 2, and B sine of pi by 2 plus theta. This, that is, it is Q is equal to actually minus A sine theta, B cos theta. So P, if P coordinate of P is this, coordinate of Q will be that, and from this one we get this. You have to keep in mind this formula as well as this formula. Now, in the present case, I erase it. Present case, M1 y is equal to M1 x means its M1, its gradient is equal to minus half. M2 of that is equal to y is equal to 4 by 3, that is M2 is equal to 4 by 3, that's all. So as because we are given that M1 M2 is equal to that, so we must have half into 4 by 3 is equal to minus B square is here, B square by 36, A square is 36, so that it is equal to negative will be cancelled and B square is equal to, it is 6, 6, 24. So B square is equal to 24. So we get B square is equal to 24. We have to find the equation of directrices. This is our major axis. So equation of directrices is x is equal to a by e, and this one is x is equal to minus a by e plus minus a by e. So we have to find e. E is equal to root over of 1 minus b square by a square is equal to root over of 1 minus 24 by 36. A square is this, b square is just now obtained. So root over of 1 minus 2 by 3. So it is 1 by root 3. 1 by 3, 1 by root 3. Okay, E. So equation of directrices is x is equal to plus minus a means 6 by 1 by root 3, so that it is equal to that. So equation of directrices is x is equal to plus minus 6 root 3. So this is correct answer. Okay, today is up to this. If you feel that this helps you, then please share it, like it, and subscribe it. Thank you.